Dear students, after the successful completion of the 17 chapters in the first PC, the 18th chapter is body fluids and circulation. So, in the beginning, blood. Blood is a fluid connective tissue. It consists of intracellular matrix called plasma, on which RBC, WBC suspended. So, plasma is yellow viscous fluid, and 55% of the blood is plasma. And 90 to 92% of plasma is only water, 6 to 8% proteins. The chief proteins of the plasma are serum albumin, globulin and fibrinogen. Serum albumin, globulin and fibrinogen. Albumin, very important point, regulates the water composition of the body fluids. And globulin, it is a defense protein. And then the fibrinogen helps in clotting. Clotting is a complex process. It involves as many as 14 factors. I will explain you about the clotting after this. And then, as I told you earlier, on the plasma, RBC, WBC, platelets are suspended. So the RBC, we know very well what are all the differences between this RBC and WBC. And then RBC, definite shape, no definite shape for WBC. More in number, that is 4 to 5 millions of RBC per cubic millimeter of blood, and here only 6,000 to 8,000 per cubic millimeter of blood, the WBC. More in number, less in number, and then enucleated. Here it is nucleated, no independent movement, there is independent movement, and red in color, and it is colorless. And the red in color because of the presence of hemoglobin. An adult man consists of about, human beings consists of about 12 to 16 grams of the hemoglobin. That is very, very important. And transport of oxygen, important function of RBC as we know. And then the WBC is of two types, that is the granulocytes and agranulocytes. Before that, lifespan of RBC 120 days. That means you can donate blood only after 4 months, because the new RBC will be originated. So 4 months, that is 120 days. And then because of this, the blood can be donated only after 4 months. The new RBC will emerge out, or else it will die within 120 days. And coming to the WBC, a few minutes are short-lived, they give in the textbook. Few minutes to few months, or it is short-lived. And as I told you, the WBC, two types, granulocytes and agranulocytes. Granulocytes are neutrophils, eosinophils, and basophils are the granulocytes. And the agranulocytes are the lymphocytes, monocytes are the agranulocytes. And the neutrophils have 3.5 lobed nucleus, and they have small, more number of granules, phagocytic in nature, and they account to 60 to 65%. And coming to the eosinophils, it is for only 2 to 3%. The eosinophils, it has a spectacle shaped nucleus, that is also very important, and it plays an important role in allergy eosinophils. Basophils are the blood cells which are present in the least amount, and it consists polylobed nuclei. Many nuclei can be seen which are polylobed, and it occurs to only 0.5, which is present in the least amount, and it secretes the heparin, serotonin and histamine, which play an important role in inflammation, etc. So these are all this is about the granulocytes. And coming to the agranulocytes, lymphocytes. Lymphocytes represent for about 20 to 25% of the blood. Lymphocytes are of two types, B lymphocytes and T lymphocytes. And the T lymphocytes are of two types, helper cells and killer cells. Killer cells are phagocytic in nature. Helper cells, they help B lymphocytes to produce antibodies. This is called as CMI, cell-mediated immunity. And coming to the B lymphocytes, they produce antibodies, that is called humoral immunity. In detail about these antibodies, you will study in the second PUC. Already I have explained and covered about this. And then platelets account to 1,50,000 to 2,50,000 platelets are present. Platelets contain fibrinogen and helps in clotting. Clotting is a complex process. It involves as many as 14 factors. So it is the first inactive prothrombin in the presence of an enzyme, thrombokinase, thromboplastin, very, very important. Thrombokinase or thromboplastin converted into active thrombin, inactive prothrombin in the presence of thrombokinase or thromboplastin. Metal calcium is required for this. It is converted into active thrombin. In the presence of active thrombin, fibrinogen, which is soluble in the blood, is converted into insoluble fibrin. As soon as fibrin forms, clotting takes place. This is according to Best and Tyler. Very, very, very important for your NEET examinations. And after this, the lymph, when the blood enters into the small capillaries, only RBC can squeeze in through the small capillaries. The rest of the fluid is called lymph. Lymph consists of plasma, WBC, platelets, but no RBC. Blood minus RBC equals lymph. And this lymph helps in the end products of fatty acids and glycerol are absorbed into the lymphatic vessels called lacteal or chyle vessel. About the lymph also in detail we will study in the second PUC. And next to this, the circulation. So we know very well the fishes have two-chambered heart and amphibians have three-chambered heart. Reptiles have three-chambered heart except crocodile, where the partition begins. And the apes and mammals have four-chambered heart. And this means that is the two-chambered heart here. The blood visits the heart only once, hence it is called single circulation. Whereas the amphibians, reptiles, there is dorsal aorta and blood visits the heart twice. That is called double circulation, but it is incomplete double circulation in case of amphibians and reptiles, because there are only two auricles and a single ventricle and mixed blood flows in the body, hence it is called incomplete double circulation. And in case of the birds, double circulation, complete double circulation as in mammals, but in birds it has right aortic arch. That means the aorta overarches above the heart towards the right side, and for us or the mammals they have left aortic arch. This is also very, very important. And coming to the heart. Heart composed of four chambers, two auricles and two ventricles. Auricles are the receiving chambers, they are also called atria, and ventricles are the distributing chambers. And superior vena cava, inferior vena cava, it is given precaval vein and the postcaval vein. Precaval and postcaval open into the right auricle. And the two pairs of pulmonary veins, that's very important. One comes from the left lung, another comes from the right lung. A pair are present and open into the left auricle. As the auricles are the receiving chambers and ventricles are the distributing chambers. Hence, the pulmonary artery arises from the right ventricle. and then it goes to the lungs, and then the aorta arises from the left ventricle and overarches above the heart, left aortic arch, and then the arteries of this aorta supply blood to almost all parts of the body. And then in between right auricle and right ventricle there is tricuspid valve, and in between left auricle and left ventricle there is bicuspid valve also called mitral valve. So heart is auto-excitable, but this is about the structure of the human heart, and there is a double circulation. First, the deoxygenated blood flows from various parts of the body through the superior vena or precaval and postcaval vein into the right auricle. At the same time, oxygenated blood after the exchange of gases comes to the left auricle through two pairs of pulmonary veins. The opening of this right pulmonary vein not given in the textbook, and here only a pair of pulmonary veins, and here the opening, but you have to remember this is very important, and from the right lungs opening of right pulmonary veins also very important. Hence the oxygenated blood flows to left auricle. When the auricles contract, deoxygenated blood flows to right ventricle, oxygenated blood flows to left ventricle, and then through auriculoventricular aperture. And these tricuspid valve, bicuspid valve prevent the backward flow of blood. So because of this, when the ventricles contract, the deoxygenated blood flows to the lungs through pulmonary artery, and the oxygenated blood from the left ventricle flows to aorta and all parts of the body. Thus, the blood visits the heart twice. That means first it comes to the heart, then goes to lungs, and then again it visits and then to all parts of the body. Hence it is called double circulation, and it is also complete double circulation. Whereas incomplete double circulation, there in amphibians and reptiles, the mixed blood flows in the body because of only one ventricle. Hence it is incomplete double circulation. Here it is double circulation. The closing and opening of the tricuspid valve and bicuspid valve produces a lub-dup sound. Lub, L-U-B, lub, D-U-P, dup sound known as heartbeat. Normal heartbeat of a person 70 to 75, that is the average is 72 heartbeats. When the left ventricle contracts, about 70 ml of blood rushes into aorta. This is known as stroke value. Amount of blood pumped out of heart, that is the stroke value, per minute called cardiac output. Per minute means it is 70 into 72, that comes about 5040 ml or 5.4 liters of blood will be pumped out per minute from the heart. This is also very important. And heartbeat lasts for 0.8 seconds. That is also very important. About the stroke volume and cardiac output, they will give you a simple problem. They may give different stroke value. Instead of 70, they may give 60, and the heartbeats also they may change, but you have to multiplication of the stroke value and number of heartbeats per minute, that will give you the cardiac output. That problem is very important for your NEET examination. That is the thing. And then heartbeat originates from a special modified muscular tissue called SAN, sino-auricular node. It is also called pacemaker. It is present at the base of the entrance of the precaval vein. And this SAN, this is SAN. Heartbeat begins from this. Hence, it is called myogenic heart, because the heartbeat begins or controlled by the muscles. And then there is one more a special modified muscular tissue called AVN, which is present between the right auricle and the right ventricle. And SAN triggers the blood supply more than 30% to the ventricles. And this is auto-excitable as and AVN catches impulses from the SAN continued as bundle of His. Bundle of His gives Purkinje fibers. Because of the Purkinje fibers distributed over the walls of the ventricles, because of the Purkinje fibers, the ventricles contract at once. Ventricles contract at once. That is also very important. And these are all the various parts associated with the heart conducting system, that is conducting system. And then we can study the heart impulses from ECG, electrocardiograph. So this is this involves P wave, and then in the diagram I will show you all these things, and QRS wave and T wave. P wave is caused because of the excitation or depolarization of the auricles, and the QRS wave, a big wave, that is formed because of the excitation or depolarization of the ventricles, and the relaxation of the ventricles, that is represented in the form of T wave, that is repolarization. So because of this we can know about the heart impulses, that is through ECG. P wave, that is, once again I will repeat, P wave, that is the depolarization of the auricles. QRS wave, depolarization or excitation of the ventricles, and the relaxation of the ventricles called repolarization. And that is about the ECG. And during doubles, the blood from the intestine will be connected to the liver. That system is called hepatic portal system, and it is the hepatic portal vein which brings blood from intestine to the liver, and this is also very important. Hepatic portal system and hepatic portal vein carries the blood from the intestine to the liver. That is also very important. So how the heart work is regulated, that is very important. As I told you earlier, heart is myogenic. That means heartbeat is regulated and controlled by special type of muscles called the special type of muscles, that is SAN and AVN. Hence heart is regulated by the muscular tissue, hence it is myogenic. And it is also the adrenaline, noradrenaline hormones also kind of regulate the heartbeat. And it is the autonomous nervous system consists of sympathetic and parasympathetic nerves. Both the hormones and sympathetic and parasympathetic, they increase the rate of heartbeat or decrease the rate of heartbeat according to need felt by an organism. Blood while flowing in the arteries, it exerts pressure on the walls of the arteries called blood pressure. Blood while flowing in the arteries, it exerts pressure on the walls of the arteries called blood pressure. Normal BP of a person 120/80 S by DHG millimeters. S means systolic pressure, diastolic pressure, Hg in millimeters. Sometimes it may reach about 140/90. That increase, that is called increase in the BP, is called hypertension. Hypertension is chiefly because of atherosclerosis, that is the cholesterol plaques, the lipid plaques, they block the arteries, and this kind of deposition is called atherosclerosis. And if the coronary arteries are blocked, so though heart contains blood to the heart muscles supplied through special type of arteries called coronary arteries. The blocking up of coronary arteries may be because of atherosclerosis, etc. And then supply of nutrients and oxygen will be deprived. And because of this, pain is felt called anginopectoris, and then the congestion of the heart, the blocking up of this heart is called cardiac failure. Because of congestion, blocking up of heart, cardiac failure, and anginopectoris, this results in the depth of segment of heart muscle called heart attack. Heart attack is really a fatal one. So this is about the disorders of the circulatory system, and about this 18th chapter, body fluids and circulation. Very important things I repeated, and I told you important at certain points. These points are very important for your NEET examination. All the best. With this I have completed 18 chapters in first PC and all chapters in second PC. I have forgotten in this chapter to explain about the blood groups. So I am adding this to this chapter, body fluids and circulation. So that is only one aspect I have forgotten. It's nothing but the blood groups, blood. So blood groups, in 1900 Carl Landsteiner discovered the blood groups, and then the ABO, A group, B group, AB group and O group. This is based on the presence or absence of two surface antigens, chemicals which can induce immune response. So chemicals which can induce immune response in the RBC, presence or absence, because of this blood groups are classified. That is, the chemical antigen is present which induces immune response. That is, if A chemical is present, A antigen, one antigen chemical called A is present, A group, that is antigen. If B is present, B group, both are present, AB group, both are absent, O group. And similarly, in the serum of the recipient, what happens? There is a protein called antibodies are produced. For A it is antibody B, for B it is antibody A, for AB nil antibodies, and for O both antibody A and antibody B is present. So blood transfusion, the process of letting blood from donor to the recipient called blood transfusion, for which blood groups should be compatible. If they are incompatible, the recipient dies due to agglutination or clumping. There is one principle involved in the transfusion of blood from one person to another person, that is, the serum of the recipient should not contain antibodies which are against to RBC antigens of the donor. Serum of the recipient should not contain antibodies which are against to RBC antigens of the donor. For example, if A is the antigen, anti-A should not present in the serum of the recipient. So this is the principle involved in the blood transfusion. So with this principle, so A can donate blood to A and AB, B can donate blood to B and AB, AB can donate to only AB, and O can donate blood to all. O is the universal donor and AB are the universal acceptors. So in the blood transfusion, there is one more important factor which plays an important role, that is called RH grouping, rhesus factor grouping. So RH positive is very common, RH negative is a very rare blood group system, This creates sometimes a problem. Only when a man with RH positive, the two dominant, marries a woman with RH negative, the child will have RH positive blood group. So during the delivery, what happens? The mixing of the mother's blood with the child, that develops antibodies. Antibodies are produced in the mother. However, the first child is not at all affected. But these antibodies are produced in large number for the subsequent delivery in case of second child. Hence, these antibodies enter into the baby, resulting in the disease called erythroblastosis vitalis, that is characterized by anemia and jaundice. But this immediately after the delivery, childbirth, if anti-RH antibodies are given, this problem can be solved. So this is about the blood groups I have forgotten, and add same to this chapter. And don't forget to subscribe. Please subscribe.